Going on, everybody? Mr. Barry here with our system of equations. Both equations are in standard form, which means the x and the y value are on the same exact side with one another for both equations. Here I'm taking a look at this one down here. Negative 2x minus 6y is equal to negative 6. Negative 7x minus 12y is equal to 15 is my other equation. We know in order to do our elimination method, which we really like when we have system with two equations in standard form, that we need to get opposite coefficients. And right now I have negative 2 and negative 7, negative 6 and negative 12. Neither pairing is an opposite coefficient scenario, and neither pairing is a same coefficient where we would multiply by negative 1. But hopefully we can take a look at these two and say, now that we know that multiplication can be used to adjust the appearance of an equation, that we can change one or maybe two of these equations in order to look similar to each other and have those opposite coefficients we need. I'm going to do that here. If I take a look at the y's, negative 6 and negative 12, 6 is actually a number that would be divisible into 12. So that might be a helpful hint to take a look at here. So what I'm going to do in this case is, since I know I have this negative 12 here, I'm going to multiply this equation by negative 2. Now, it doesn't really do much for us in terms of the x coefficient or the constant, but when I multiply negative 6y times negative 2, that would give me positive 12y, and now I can see that I have opposite coefficients for our y values. I'll scratch that out. I'll add my like terms, negative 3x. Negative 12y plus 12y, that's 0. That's where our elimination would occur. And I have a 15 plus 12 is 27. So I get x is equal to negative 9. Not good enough. I need to make sure that I get a y value to go along with that x because we're dealing with solutions that are points on a graph. I'll take the negative 9 and plug it in. I'll go ahead and use the one in red here. Doesn't matter which equation you choose to plug it into at the top. Just make sure you do the right math work. Multiplication there when we substitute that value in. And now I'm doing my two-step equation work, getting all of my variables on one side, getting my constants on the other. And it looks like I get y is equal to 4. The point value here that would be the solution to my system would be the location at the point negative 9, 4 for this system of equations.